This instructional video will demonstrate how to find the pH of a weak acid or base. In this case, we'll be using the weak base, hydrazine. We have an initial concentration, a Kb for it, and the correct reaction. So the next step then is to write out the ice table for initial concentration, the change in concentration, and what we expect it to be at equilibrium. So we have that the initial amount is 0.1 molar. We don't have to worry about water because it doesn't participate in the equilibrium. We have no common ions to worry about. Everything is 1-to-1, so for every amount of hydrazine we use up, we will pick up the same amount in our ions. Equilibrium then is the sum of those two lines. And now all we have to do is substitute into the Kb expression and apply the approximation method. So our Kb is going to be the product of our two ions. So that's X and X divided by the reactant minus X. And so by the approximation method, we assume that the amount of change is very small relative to the initial amount. And so by approximation, this gives us 1.26 times 10 to the negative 6 is equal to x squared divided by, let's go with 1 times 10 to the negative 1. And so now we can simplify this out. This gives us 1.26 times 10 to the negative 7 equals x squared. And the value we get for x when we take the square root of everything is 3.55 times 10 to the negative 4. And so the only thing left to do is to check this value against the 5% rule. If the amount of change is in fact less than 5% of the starting amount, then we're able to use the result we've calculated. So we do x divided by this initial amount, and we find ourselves with 3.55 times 10 to the negative 3. And this is 0.355%. And so with this value, we find that this passes. So we're able to use this amount for X. Now, this is the hydroxide ion concentration. And so we're going to have to take the negative log of this, 3.55. So if we take the negative log of this, this will give us our pOH, and that value is 3.45. Since pH plus pOH equals 14, we subtract this value from 14 to give us the pH, which comes out to 10.55. Because this worked using the approximation method, we are good to stop here.